All right, so thanks for joining us. I'm Dan Katz from University of Illinois. We're going to be talking about the computational infrastructure for geodynamics, or SIG, today with two people. First, Lorraine Hwang. Do you want to introduce yourself briefly, Lorraine?
Yes, hi, my name is Lorraine Hwang. I am at UC Davis, and I am the director for the Computational Infrastructure for Geodynamics, also known as CIG.
Can you tell us a little bit about CIG?
So CIG is a community-driven organization that advances earth sciences by developing and disseminating software for geophysics and related fields. We were first established in about 2005 to solve the sort of hero code and reuse issues in software. These are the very traditional models of how software had been developed. The geodynamicists at the time realized there was an inordinate amount of software being sort of created and discarded with every sort of churn of a sort of a graduate student cycle. And they thought there would be a much better way to do this, such that codes could be reused and they could be built more robustly.
Okay, thank you. And then the second guest here is Rene. Rene, do you want to briefly introduce yourself?
Yeah, sure. Hi, my name is Rene Gassmoller. I'm a computational geodynamicist at the University of Florida. I'm also the maintainer of one of the software packages that is supported by SIG, and that's how I got involved in SIG. And now I'm also teaching at workshops that are organized by SIG, and I'm involved in maintaining the technical infrastructure and also maintaining the social infrastructure of the projects that we support.
Lorraine, maybe you can talk a little bit about how SIG works as a team and how different people come together within the organization itself, and then we'll talk maybe about some of the specific projects as well.
So CIG has about 89 member institutions worldwide. They're both come from academia, national labs, and other government agencies. And that probably represents about 1,000 participants who are sort of keeping touch with CIG through our various mechanisms. As a community-driven organization, we heavily rely on governance. We have both elected governance and appointed working groups that help drive development and directions for the community. So a lot of our software projects receive advice from and as well as insight from some of our working groups as well as governance.
And I guess, Rene, from what you were saying, it sounds like you kind of came in in a role in a particular project and then have become part of the overall team as well. Is that right?
Yeah, that's correct. So I came from a purely science background, and I started working with one of the CIG software packages, and I took over more responsibility within that project first before I then moved as a project scientist to the CIG headquarters, where I then also started to help out the other SIG projects and try to look into the larger infrastructure, so to speak, like the umbrella above all of the individual projects. And that's also how I got involved with the Better Scientific Software Initiative from the Department of Energy Exascale project.
So perhaps one or both of you maybe could say a little bit about how SIG has worked, and if there are things that you've done in particular to encourage people to collaborate and to work together at the organizational level.
Yeah. So I wanted to add to what Rene said. Rene sort of represents sort of the evolution of CIG and how CIG develops software. I think originally when CIG first started, we had this model of there was just this core set of developers, and they were going to provide code to the community, and we sort of kind of flipped that on its side a little bit. And when we say develop and disseminate now, develop and disseminate is coming closer and closer together, is that we're starting to build software communities through hackathons in which we bring developers and users together. So in that way, they are collaborating both on developing the software, creating communities, creating collaborations, and that is helping to disseminate the software into the community.
So in terms of individual projects, so Rene, you said you are on one of the projects. Can you talk a little bit about how that project works in terms of teams and people and the social aspects?
Yeah, absolutely. So the project that I'm most involved with and that got me into working with SIG is called Aspect, the advanced solver for problems in Earth's convection. And it was started about 10 years ago with support by CIG. So CIG funded the original 2 developers that started the project. And since then, the project has grown enormously because it focused so much on the community development part. So the initial core infrastructure was built mainly by these 2 maintainers, but then the software has a very flexible plugin system that allows to add individual pieces. And over time, the developers focused a lot on integrating more and more members into this project. Every time somebody wanted to implement a new feature, they were involved in the development. The maintainers spent time training them and showing them how to develop the features that they needed. And that way they became part of the development team. And that's how the community grew over time. So by now we have more than 100 people who contributed to the software at some point. Many of them just very little, just the tiny part that they needed. But that means all of this functionality was integrated to the larger project. And this was very successful for us in this approach. And since then, CIG has started expanding this approach to other software projects within the SIG umbrella, or it essentially developed this approach at the same time as Aspect also developed this approach. So by now, several of the other CIG projects essentially work similarly, trying to get new users into the development. And we do that mainly through communication over like virtually a forum or an email list, but also we have annual developer workshops where we bring everyone together, the maintainers and users who are interested in implementing new features.
Yeah, Aspect is actually currently happening right now, actually. It's on its 8th hackathon. And every year we try to bring together around 24 to 25 people. Usually we stuff them all into some large house to work on code for 10 days. And every year we sort of add 5 new bodies-ish, new developers to the group. And over this cycle, I think we probably have almost 100 contributors to the code. And our other communities saw this, and they, like I think a lot of developers who start a code, looked at this and said, like, maintaining and developing this code is kind of crushing us. We need some help. And they saw what was happening to the Aspect and the capabilities of that community. So they slowly started adopting the model. Right now we have 3 out of our 4 community codes doing hackathons. Most of them are only into their 2nd or 3rd year of doing them. But I think everybody in the community is finding it really, really rewarding, and it's helping both to reduce the load on the developers and as well as sort of decrease our bust factor.
So it's interesting that basically you're using the projects or communication between the projects in some ways as kind of best practices coming from one that can influence the others. I'm also curious, do the projects actually work together in any other way in terms of the code? Is there any kind of code collaboration between different projects?
So as far as I'm aware, there is no direct reuse of code at the moment. We had tried, actually, maybe Lorraine can say more about this. At the beginning, CIG had tried to build actual common scientific software infrastructure that would be used by different projects. But we discovered that one of the problems there was to make that useful enough for all of the projects to fit it into their frameworks. And unless it was perfectly designed and to easily fit into the projects, it would always be this remote part that is kind of attached to the software instead of tightly integrated. So at the moment, there is not really a part of software where we would say this software is used by several of our projects. But what we do a lot is we talk a lot about how we do things and do things similarly in different projects that have worked well. So we try to share best practices about the continuous integration, for example, or community policies, or pull request review, these kind of things.
What we do try to do is we try to build on well-used computational libraries. Most of our codes use numerical libraries like DEAL2, Trilinos, and PETC. And through these, the usage, we've actually had some great collaborations with the computational scientists from those groups and have been able to contribute back to those communities. I think looking forward, we do want to address this issue about common infrastructure for our codes. And it's something we're looking at very closely to more tightly integrate what we do along common formats and some common tools for our codes.
Okay, well, thanks. Thanks to both of you for your time. I don't know if there's any kind of closing thoughts that you want to leave us with. If so, please go ahead.
Well, I guess for this event, we don't really need any closing thoughts, because the main message of this event is that the social aspect of software development for scientific software is important, and that is exactly what we noticed to build up the CIG software over time. That only software that is organized in a way that people feel welcome in the project also tends to grow over time into larger software projects.
Yeah, and I want to say that it really is as much as about the science and the code as it's about the community. Over the years, through these hackathons, Aspect has become a really, really close community. And as I reflect on my own sort of career in the sciences, is that these sorts of interactions between early career researchers are really long lasting, and they become long lasting collaborations. Projects I'm currently working on are with people I haven't collaborated probably since graduate school, but I'm now coming full circle back and working on research projects and community projects with them. So it's been really rewarding to see that arc.
Okay, well, great. So thanks again to both of you for being willing to participate here, and it's great to hear about the successes of teams and within the CIG. So thank you.
Thank you.